Okay, welcome everyone. It is my pleasure to introduce Saranya Ravva. She is an analog astronaut and holds a Guinness World Record in light pollution. And she will be speaking to us today on sanitation in a Mars habitat. Welcome, Saranya.
Hello everyone. Thanks for the warm welcome first of all. I'm really excited to be a part of International Mars Convention, and this is my first time here. Greetings from India as well. Today I would like to discuss about sanitation functions in a Mars habitat. I would like to share my screen real quick. Just a second. Is my screen visible?
Yes, it is, Saranya.
Yes. Okay, thank you. Yeah, so let's discuss about the topic, which is sanitation in a Mars habitat. So yeah, sanitation, which is one of the most overlooked or a very ignored topic. I feel it is a very ignored topic when it comes to missions like this. So today I would like to focus on that, sanitation, an easily overlooked yet critical element of long duration Martian missions, which we have to deal with the garbage which we humans inevitably produce. We have no other way but to take out this waste and use it in a proper way, make resources out of it. So let's look into some of the solutions which I found out which might be helpful in a Mars habitat. So yeah, here you can see a few elements of sanitation in this picture. These elements, no matter wherever we are on the Earth, are going to be the same. And yeah, for proper functioning of a habitat, say wherever we are on Earth, on Mars, on Moon, on wherever we are, sanitation has to be one of the main key role, and it has to be taken care of. And yeah, just not sanitation, but the sanitation has to be a closed loop system. What I mean by closed loop system is that it has to be a sustainable system, and it has to use all the regenerative methods. And I would like to discuss about few technologies in this presentation, which I think might be helpful for sanitation and getting all those resources which we want. So main elements, the key elements of sanitation are, first thing, which is waste collection and processing. For this, we might have to follow a lot of protocols, which will help us to save up a lot of time. Then second important aspect is waste recycling into required products. That is where the sustainability actually starts from. And then the third aspect, which is atmosphere maintenance. Unlike Earth, Mars is not having the same kind of atmosphere. So it is very important for us to have that Earth-like atmosphere even on Mars, so that it helps for proper life support system for the crew and for all the things we are trying to do on Mars. And atmosphere maintenance can be done using air filters, where you can eliminate the dust particles, because there are a lot of dust dunes on Mars. That's a main issue we have to take care of. And then we need to have airlocks, so that we are pressurized and unwanted waste is not entered into the habitat, or the internal part of the habitat at least. Then yeah, sanitation, just not sanitation, but the sanitation has to be very sustainable. So sustainable sanitation is definitely going to be a catalyst for development. So when I say catalyst, why do I say it a catalyst? Because this sanitation can be indeed used to generate a lot of products, like, say, first thing, in the production of biogas. You can use biogas for cooking on Earth. There are a lot of households which use biogas, and they use it for cooking and a lot of other purposes. Then fertilizers, say these fertilizers can be, for growing crops, like Martian movie, I think you might be knowing, where Matt Damon actually grows potato using the human feces in a very weird and interesting way. Then yeah, this waste can also be used in producing hydrogen fuel. and then brick making, used for biomass, source of water, protein-rich minerals, and a lot more. So this is one thing which I would like to tell about, which is cosmic radiation shield. On Mars, unlike Earth, there's also a lot of cosmic rays which are happening, which is very harmful for humans. And one way for us to protect us from that cosmic rays is to have some kind of shield. And in a very weird and interesting manner again, there was a research conducted on International Space Station where human waste together with water and food was actually, it can actually be used in form of bags, and it can be used as a shield against radiation. And the reason being is that liquid like water is a better shield than metal because it has got more nuclei per volume, which is actually the key to block the cosmic radiation. So these can be few things or resources which can be produced from the waste, and where we can have sustainable sanitation. Then yeah, the main aspect of this presentation is about these technologies. I have mainly found these technologies from the Gates Reinvent the Toilet Exchange Challenge by the Gate Foundation. So first one being the nano membrane toilet. This one was very fascinating because this is indeed like a flush and forget mechanism. You know, it treats human waste on site without external energy or water. I'll give all the credits to Cranfield University. It's their startup, and their main idea is to, take in the waste and give out some kind of water, not really drinking water, but water which can be used for other purposes. Here, so I would like to briefly explain how this particular nanomembrane toilet works. So there is a rotating flush here. Once the person has done his job, they just have to close this flush, and all the waste, gets collected into a particular chamber through an through a rotating flush. And because of the density, the solid gets deposited in the down and the liquid goes up. So whatever solid is there, using this Archimedes screw, it travels from the top position to this position. And this screw basically divides the solid into small pellets, and it transfers into a gas combustor where spark is ignited and these small pellets of solid are burnt. And when these are burnt, heat is produced, right? And this particular heat is produced, used as a heat to heat up the water, the other liquid waste. And this water is passed through some kind of sweep gases and other gases where it removes all the pathogens. And then there is a reservoir and tank where you can collect all of this water and indeed use it for any other purposes you want. So basically, this particular toilet is actually not utilizing any external source, but indeed it is giving out something else from it. So here is a quick brief about it. Then I would like to talk about Omniprocessor. This is again, I have bought this reference again from the Gates Foundation's conference as well. So the Janinki Omniprocessor works in a very large scale manner. This was actually tested and proven on Earth. So a large scale of human waste was taken into it, and all that solid was burnt up, and whatever steam was produced from that was taken into a steam generator, and it was giving out electricity. That electricity was not only required to power up this whole processor, but also there was extra amount of electricity which was used to power up something else as well in a particular city on Earth. And then this there's another water, right? So again, here heat is passed and dryer and sweep gases and everything, there are filters and everything where filters are used, UV filters, just like we have RO purifiers and all of that, reverse osmosis and all those processes like pyrolysis and all that. The end product is literally drinking water, and it is proven and tested that it actually works. So I feel that when, say, after 50 or 100 years, when we expect to have colonies on Mars, Omniprocessor would be a very great initiative for us to use to extract resources from human waste, wherein we are getting electricity, water, and we are eliminating the waste altogether. And yeah, another interesting fact, since here I have spoken about using it in brick making, so either from nanomembrane toilet or from Omniprocessor, there is some kind of ash produced, right, from the solid which is burnt. This particular ash, when mixed up with oils or some other additives, this can be actually used to make some kind of bricks and something like that. And indeed, again, we can probably use these bricks for something else. So more sustainable solutions. Yeah, then yes, I would like to talk about smart sanitation. Smart sanitation is where usage of sensors in every particular center, say there's a habitat in the power station, in greenhouse, everywhere there are going to be washrooms and toilets, right? So there we can use these sensors so that they capture the molecular characterizations of the waste, and they transmit the data to, say, a center called sanitation center. And these people analyze the data, and then it can be used later on for repair, cleaning, waste collection, and anything. This smart sanitation actually makes the job pretty much handy and easy. And obviously these should also have a lot of protocols like regular maintenance and all of that. Then yeah, another technological solution which I found to be interesting is nanotechnology. So I think, you know, lotus plant. Lotus is actually an Asian aquatic plant. Lotus effect is one thing, basically. So lotus effect is where it has super hydrophobic properties, where it does not absorb the water. The lotus plant actually grows in dirty water, but still it looks very fresh. That's because of its hydrophobic properties. A lot of research was actually conducted on that, and the same kind of solution was actually used at nano level in making a lot of clothing solutions, where these clothing solutions can be actually used, you know, here as you can see, it is not at all absorbing any kind of dirt or water, and it is still fresh. And yeah, nanotechnology can also be used to control heat. Mars has a very unpredictable atmosphere, so we can probably use nanotechnology, wherein these solutions help us to maintain body temperature just the way we want it. So I think nanotechnology can be used in making spacesuits in further missions. Then yeah, so architecture of sanitation center mainly depends upon crew and habitat size. So we need to have autonomous boats and specific crew responsibilities, you know, for regular waste management and collection. So if there's a bigger crew, obviously we might need a sewage treatment plant wherein it takes the waste to an Omniprocessor. But say we have a small crew, say it's just the first generation of astronauts going on Mars, then probably we can have smart sanitation as well as nanomembrane toilets, and probably that would be enough for now. Then yeah, since we have discussed about waste management and water management a bit, now let's discuss about atmosphere maintenance. So atmosphere maintenance mainly deals about the main resource for humans to be alive, which is oxygen. Oxygen content on Mars is like very low. So it's very important for us to always monitor level of oxygen and have the backup of oxygen. So one aspect of oxygen level, then removal of excess CO2 from the centers or from the spacesuits, then maintaining atmospheric conditions like adequate pressure, temperature, and humidity should be taken care of. Yeah, because of the dust dunes, dust management is one such thing which should be mainly taken care of, unlike Earth. yeah, since I discussed about nanotechnology, this nanotechnology can be actually used where the suits are, the material of the habitat is prone to dust. Even that aspect can be considered. Then indoor air quality has to be mentioned. Then aspects of HVAC, which is heating, ventilation, and air conditioning also play a very major role in maintaining the atmosphere. Yeah, I hope most of us know about MOXIE, which is an instrument which is being carried out on Perseverance, which just is probably on the way to Mars right now. I'm really looking forward to MOXIE's results, because MOXIE is a very interesting instrument wherein it is going to produce oxygen from the atmospheric carbon dioxide of Mars. And if this particular instrument goes into a real success, it is definitely going to be a revolution, because production of oxygen is indeed a bigger achievement for us. I'm really looking forward for MOXIE's results. Then, yeah, when we're looking at sanitation, we should also look at aspects like personal hygiene. So, yeah, so obviously, personal hygiene, we don't usually think about it like washing clothes and all of that. We can't load up our resources. We can't load up with a lot of resources, right? So the journey might be for around 6 months. Say we are staying for another 3 months. There is going to be a lot of baggage which we might need, and that can be eliminated by using a few solutions like, see, this is an LG styler. It is basically like a fridge, a refrigerator, wherein you just have to hang up your clothes and it pretty much freezes it up, removes the pathogens, gives you back fresh clothes. So basically here you're using you're using fresh clothes without even washing them. So no usage of water. This is one interesting solution which I thought might be useful. Then this is actually a very age-old solution, which is washing clothes without water. And I was very fascinated by the idea, because it was actually using these nylon polymer beads. And those are not just 10, 20 of them, but there are millions of beads like this, where these beads travel around the clothes and they remove the dirt. This was another interesting thing which I found out. See, there are beads in this particular machine, and the clothes are rotated and the dirt is removed as the beads interact with the clothes, because of the friction produced between them. Probably we can just have one kind of a machine like this in the habitat, which saves up a lot of water. Yeah, I spoke about freezing clothes. Then we can also use steam to clean up these clothes. Wardrobe, this is a wardrobe that refreshes and deodorizes clothes rather than washing them. Yeah, another aspect is dental hygiene. Yes, as I discussed earlier, spacesuits with low dust retention and release, which are comfortable and ease of movement, should be taken care of. These kind of aspects like physical hygiene, personal hygiene, all of them not only affect in physical health of the astronaut, but also affect mentally. When you feel good, you do good, everything reflects well. So I thought this is one of the major aspects in sanitation. Then yeah, let's look at the resources. So here, now I got this table from internet, and here it was actually comparing the usage of different kind of resources like oxygen, drinking water, food, and everything else compared to Earth, and how it actually is going to look like on space. So in space, sorry. So the reduction amounts, as you can see here, are very much tremendous, and these should be actually mentally and physically the astronauts should be prepared for it, because as you can see, this is a tremendous decrease of the usage of resources. Yeah, so this is another aspect which we have to take care of, which we have to be prepared for. Then let's get into the next one, which is, just a minute. Yeah. So yeah, another major aspect, which is life support system. So here I would like to discuss about the life support system with this simple diagram, wherein say this is the Martians, these are the Martians, or these are the crew. So basically they require oxygen that's coming from one particular area, and that is another system. There's another system which is taking out the excess CO2 out of this life support system. Then there is another system which is taking care of temperature and humidity control. And yeah, there is cabin air, cabin written, all of this. Then due to emergencies like fire or anything, there has to be another emergency system like this. Now let's look at the actual sanitation part, wherein the processed urine or the urine recovery is taken place, the waste products are done, where waste management is taken care of. Then potable water processing. Now see here, you can use this particular water which you have cleaned up, or some kind of drinking water, for several uses like showering, hand wash, whatnot, anything, and any human purpose. So this is basically, I think, how a life support system is going to look like in a very generalized manner. Then, yes, this is a clip from my favorite movie again, which is Martian, where you can see Matt Damon actually planting a lot of plants out of human feces. He basically makes potatoes out of them. This particular idea was actually very fascinating, and I kind of imagine this kind of situation happening in real time as well. So here again, he uses the biomass, and yeah, he also produces water here using the hydraxin and fuel like that. So this movie is actually like a practical approach for people like us. Yeah. Then few protocols which can be followed by a sanitation facility are that all the regular communication should be done with the center to enable hygiene and maintenance. Air filters should be installed and maintained in each facilities. Then if there's any malfunction, it has to be immediately reported. Then the airlock should be definitely placed in front of every entrance of the facility or the habitat. Regular collection of waste, recycling of the waste, all the protocols must be followed. These are like very general protocols which I think must be followed. Then,
excuse me, Saranya, we're approaching the end of the hour, so we need to, if you could wrap it up in about a minute, that will give our attendees time to ask you some questions.
Sure. I'm almost at the end. Yeah, these are few activities which can be taken care of. You can have a look here. Then these are few references. Then I would like to talk about Habitat Mati. Whatever I have spoken so far are the findings from mission 46 and 47 of our virtual analog missions. And I was actually the sanitation center chief of this particular virtual mission. You can totally have a look of Habitat Mate through this website, and you can get to participate as an analog astronaut just like me by contacting through this websites. And thank you for this wonderful opportunity, and I'm open for questions.
Okay, Priscilla, did we have any questions?
Yes, so we have a few questions. So thank you very much, Ms. Ravva, for your talk. And the first question is that the same system like we actually have in the ISS?
Actually, in ISS, it's a very complicated system. This nanomembrane toilet is entirely different from the actual ISS toilet one. ISS actually uses something similar to Earth kind of system. So I would say it's a bit different.
Okay, thank you. So the next question is, which of these solutions will be most practical to test in Mars analog stations for evaluation?
So we have spoken about, say, 3 to 4 technologies. Out of these technologies, I would say using smart sanitation would be very easy, because we have a lot of sensors available which will calculate this molecular, consideration and give us the required data. I think we could start with smart sanitation first and then proceed with other solutions, because nanomembrane toilet and Omniprocessor are actually a large scale projects and they're all under process. So I think going with smart sanitation might help us. Yeah.
Okay, thank you. So the next question is, how would you incorporate agricultural production into waste management?
Sorry, I didn't get it. How would I incorporate?
How would you incorporate agricultural production into waste management?
Agricultural production. Okay.
Yeah.
So since we are talking about making the most out of the waste, we can use this waste as a biofertilizer, and it can be used in growing the crops. This approach is actually observed even on Earth, mainly observed in India where I live. It's actually a very traditional approach. Then this particular waste can also be converted into biogas, and this gas can be used for cooking and all of that. So yeah, this is actually in a very smaller extent, but I would say if we can use it, then it's pretty much an amazing resource.
Okay, so the last question is, would a static electron plate at external doorways with an on-off switch to ionize particle work to mitigate dust contamination?
Okay, interesting question. I'm not really very familiar with it, but yeah, a static electron plate at external doorways with on and off to ionized particles. Probably we could try it out in a small scale experiment maybe, because as the mechanism goes in, the internal structure, which will actually absorb all the dust particles, probably we can give it a try in a smaller scale as an experiment, and then probably we might incorporate in the actual habitats.
So thank you. And the last question is, how bulky is the technology for the nanotechnology for clothing?
Sorry. How?
Carol, can you tell the question?
Yes, thank you. How bulky or how big and weighty and heavy would the technology be for using the nanotechnology to create that the clothing?
Spacesuits.
Yeah.
Okay. So when I'm telling nanotechnology, it all depends upon the interior part of it. So when we go at the nano size of the manufacturing process, I think there are actually a lot of solutions right now, a lot of feasible and functional solutions in the market, which are currently using nanotechnology. Say I'm using a wristband here. It has aqua hydrophobic properties. It doesn't actually absorb water. So yeah, for a larger level like a spacesuit, it definitely requires a lot of research, and it might also cost us a lot. Yeah, it majorly depends upon studying the material properties and all of that. Yes.
Okay, so that was the last question. So thank you very much again, Ms. Ravva, and thank you all of you for your attention.
Thank you so much.
Yeah.
Okay, we will be closing this meeting out. Thank you, Saranya. Everyone have a good time and continue watching the conference, please.
Yes.